the back? All right, cool. I'll just give a minute for people to keep on walking in, but while we do, I want to do my customary how much of these technologies are people using thing. So give me a quick show of hands if you use Angular, React, Knockout, or some other thing like that in your day-to-day work? Yeah, everyone. OK, that's not surprising. How many of you specifically Angular, then? All right, that's like probably more than a half. And React? That's most of the remainder, probably like a third. And Knockout? Oh, actually, that's another third. So some of you are using more than one thing. Anything else? Aurelia? Yeah, that's smallish, but that's not reached 1.0 yet, so that's reasonable. OK. Cool. All right, then. So yeah, my name's Steve, and I work at Microsoft on the ASP.NET team. And my particular area of focus is trying to make sure that everything that we build is going to give you a really good experience as a client-side application developer. So whatever technology package that you like to use, we want to make sure that it's all going to fall together quite nicely for you. So let's think for a little minute before we start looking at some code about the history of how we've got to where we are now and whether or not it's already good or bad or to what extent. So let's start by taking a little step back in history. We'll go as far back into recorded history as we can, right to the very beginning of when historians can first start recording history, which is 2003. And we'll think about the sort of skills that you needed as a web developer back then. Okay, so if you wanted a job in this industry back then, you would need to be able to do some HTML, you'd write some JavaScript, probably for some validation logic or to make some annoying pop-ups appear or something like that. You would be doing some styling with CSS, you would inevitably be writing some SQL to talk to a relational database, and you will be doing some server-side programming with ASP.NET, PHP, or some Java-based thing, probably. OK, so how have things changed since then? What's the landscape, and what are we asking now of not our rock star web developers, but our typical bog-standard entrants to the industry? Well, these days, it's not enough just to know JavaScript, obviously. There's quite a lot of different languages that compile to JavaScript that you're going to have to be familiar with, TypeScript, notably, but also different versions of JavaScript itself, different standards, ES 2015, ES 2016, and so on, that they'll have to get used to. After that, you need to start thinking about what frameworks you want to use. You enter this murky world of picking your favorite client-side model view library, as well as your favorite libraries for all kinds of other tasks, like to do with rendering 3D graphics or anything else. So lots of libraries that you're going to have to learn. That alone is not quite enough to write your application because you have to make some other choices. For example, what kind of client-side application architecture do you want to use? It's not just MVC these days. We've now got things like Redux and other members of the Flux family that are bidding for our attention there. OK, so when you've got all this stuff together, you can probably start to write some code. But then you need to think about how it's going to get into the browser and get executed. There are many, many different systems for packaging, bundling, and distributing code, and for actually getting it to load inside browsers, for making references between modules and so on, that you have to understand the pros and cons of different options there. But you don't just write these bundles by hand. Obviously, you're going to need to use some sort of build tool. And there are many, many, many different build tools that you need to trade off and make the right choice among. Now, for the really old school ones among you, you could use something like Gulp or Grunt, but to be honest, they were around in 2014. So most of us have moved on numerous times since then. And these days, we'll be using things like Webpack and Rollup and something that someone came up with this morning or whatever. OK, and that's not to even mention any of the advances that have happened in the world of styling, which is a whole discipline in its own right, which I know very little about. But they've got their whole collection of technologies now in order to write effective and maintainable styles. OK, so that's a good portion of your application. But as well as that, these days, we also now are concerned about the different platforms that our code is need to run on. It's not just desktop browsers anymore, obviously. It's not even just mobile browsers, which themselves have got a whole set of different capabilities and UI interaction paradigms. Now we also need to think about, if we're building a really modern application, maybe our client-side code doesn't just run on the client. Maybe it's a universal or isomorphic app where our JavaScript runs on the server just as well as it runs in the browser and transparently switches between the two. So there's so many different concepts that are all coming together to make a current-day web application. So how does this fit into the bigger picture then? Because when we think about the technology landscape as a whole, what we see is that over time, all technologies get more and more streamlined and simplified and approachable, except for web development, which over time just gets more and more and more complicated. And why is this? So I did a bit of research into it, and it might have just been my jet lag, or it might be my innate genius, I don't know, but I've come up with some ideas about what's actually going on. So I did a bit of research using this advanced research tool called Google Trends, and it confirmed what we all know, which is that JavaScript frameworks have been growing and growing and growing in their pull on human attention since 2011. And you can easily confirm this for yourself, right? Because after this talk, you can go out into the street and you can ask anyone that walks past, like, what's the biggest change that's happened in the world over the last 5 years? And every one of them will say the proliferation of JavaScript frameworks, right? Because that's easily the biggest shift in human culture over that period. But is this just a standalone thing, or does this tie in with some other cultural or political shifts that are going on? Well, I think that I might be onto something here, because if we plot this alongside the terrifying global rise in extreme right-wing politics, we'll see they seem to correlate a little bit. I mean, is it just a coincidence that they seem to have grown at the same rate at the same time? Could it really be a coincidence? And if you're not convinced about this, look what happens if I also overlay the scary rise of superhero reboot movies, right? Definitely something is going on here. And I know whenever you show a graph like that, all the scientists in the room, they all just want to jump up and down and shout, correlation equals causation. Yeah, I think that's right. Yeah, we know, okay, yeah. So it's pretty convincing evidence that something is driving this worrying growth in complexity for us as JavaScript developers. So what are we going to do to fight back against that? Well, in the ASP.NET team, we are trying to make lives better for ourselves and for everyone else, and we can't solve all of these problems. We can't take on the superhero reboot movies thing, but we can try and help you with your single-page applications. And that's what I'm going to be talking to you about in this talk. So here are a few sort of high-level ideas. One is that we can try and make sure that whatever code you write on the client is going to play very nicely with the code that you write on your server. And that means having the right sort of packages and API and hook points and so on, that the sort of server-side and client-side code can play together nicely. Another thing would be to accept the fact that today your JavaScript probably doesn't just run on the client, but may well need to run on the server too. There are lots of reasons why you might want to have server-side JavaScript, and we'll be getting to that later in this talk. And then finally, and sort of more obviously, just making sure that you have a really good developer experience. And that starts with your file new project, and it runs through all the deployment and debugging and everything like that. And that will be a major part of what I talk about in this talk today. So that's where I'm going to start, in fact. I'm going to start with the experience of getting started with the new project. And I'm going to run you through a set of project templates that I've been prototyping lately and are now out in beta form. And these are some project templates for Angular 2, current version of Angular, for React, for Knockout, and for React with Redux. Now, these are not the only client-side technologies, obviously. There's someone in the front row with an Aurelia t-shirt on, and if I were to go through the list, there are probably 20 other JavaScript frameworks represented in this room. So the idea here is not just that you can only use one of those four, but rather that the underlying technologies that provide the functionality I'll cover in this talk are available to you to use in whatever kind of project you want, whether it's for a different client-side application framework or for just some crazy project structure that you come up with on your own. And I'll be showing you that later on in this talk. Okay, so let's get started, and I'll talk you through the process of creating a project, and then we'll look at some of the features that we're putting in to make sure that you have a really good developer experience. So let's say that we want to make a new Angular 2 project that works with ASP.NET Core. So you can get these beta project templates today, and you do that by getting them as Yeoman templates. Yeoman is a node-based project scaffolding system. We've shipped ASP.NET templates on Yeoman for quite a long time, and these SPA templates are on Yeoman right now. We will probably also make them available through other methods in the future, but for now, if you want to get them, you will go to any machine that's got Node.js installed and write this: npm install globally Yo, that's for Yeoman, and then generator ASP.NET Core SPA, single page application. Press go and wait for it to fetch all the stuff. I will not wait for it because I don't have an internet connection, so it would not work very well. But I've already got it installed, so that's fine. And then you can create your new project. So let's do that right now. I'll do make dir my new thing. OK, let's go into there. And I can say, Yeoman, please create for me a ASP.NET Core single-page application. And it will say, OK, fine. What framework do you want to use? Here are some options for you. OK, let's say we want Angular 2. What's the name of your project? It doesn't matter. We'll just let it do that. And it will now restore all the dependencies, and we've got a nicely structured project that I'm going to talk you through. Now, obviously, this restore process won't work in the absence of an internet connection, so we'll kill that. And we will delete that, and we'll go into the one that I already prepared. OK, so here's my file new Angular project, and let me get that started, and then I'll start showing you some of the code and some of the things that we can do that. So I'm going to go, what is it now, .NET watch run. So I'm going to run .NET over my ASP.NET application there, and it's watching for any changes to C# files, and it will recompile and restart if it sees any. And it says, OK, I'm listening on port 5000. OK, so let's put that into our browser, and we'll see what comes up there. And we will see overside. There we go. That's better. All right. So we will see our starting point for an application. And it looks a little bit different to the normal file new projects for ASP.NET applications. The reason for that is that those normal file new projects are largely designed with some sort of public-facing website in mind. But the kind of navigational structure and layout that you probably want use for a single-page application is probably a bit different, because you're probably going to be building something like an administrator console or a dashboard or something like that. Otherwise, you wouldn't be using these sort of technologies. Hence the slightly different layout. But it's just Bootstrap, so obviously you can change it to look and be laid out anyway, anything that you like. Anyway, it starts with a bit of information about some of the features and technologies in there. And let me just quickly run through some other stuff. So it's got a few different pages, and it's got back-forward navigation. This is purely client-side navigation, so it's not doing requests to the server every time I move backwards and forwards. It's within the single-page application. We've got this very, very simple example of an Angular 2 component, which just has a button, and when you click it, it counts how many times you've clicked it. So that gives you a very simple sense of how you can write something like that. And it's also got an example of how you could fetch some data from your ASP.NET server on the back end and display that in a grid. So let's have a look at some code that's in there. Let's see how it's actually structured. And here is my code. And you can probably see, if you've used any ASP.NET MVC applications in the past or ASP.NET Core, that it's more or less like those. It's got all the normal server-side stuff. We've got our controllers folder, we've got views, we've got startup CS, and so on. The main things that are different about it is that we've got this client app folder up here, which has got the whole Angular 2 application in it. And we've got a bunch of extra config files down here at the bottom to do with TypeScript and Webpack, which we'll talk about later on in this talk. So what's in this client app folder? Well, it's all the stuff that you need for a normal Angular 2 kind of application. For example, we've got a routing configuration. This is client-side routing, so this is matching all those different URL patterns that you were seeing me navigate through a minute ago. And that references these different components that can get rendered. For example, there is this counter component. And if we have a look at the code for that, it's pretty nice and simple. So it's written with TypeScript, and it says, right, let's import the Angular libraries, and we'll give it this name, ng. And we'll tell Angular to regard this class as being a component. And the logic for it is really simple. We just have a current count member property. It starts off at 0, and whenever we call this method, it goes up by 1. Not too hard. And that's all linked together with this template, counter HTML. And inside there, you can see that all we do is use Angular 2 view syntax to display the current count. And we've got a button that, when you click it, it increments the count. Pretty straightforward. And that's how that works. OK, so pretty predictable kind of stuff. So what are we really contributing with these project templates? How are they different from what you would have just set up immediately within 2 minutes on your own anyway? Well, there's quite a lot of fiddly plumbing going on if you want to have some more advanced features that are representative of 2016 style web development. And I'm going to walk you through some of these things, and they are a pain to set up, and that's essentially what we're taking the work away from you of having already done that in advance. So let me run through some of them. The first one is kind of a bit boring, and I'm not going to show you any code for it. So you've got a server-side routing configuration in ASP.NET. You've also got a client-side routing configuration in Angular, React, or really, or whatever else you like. Now, you want these things to work together nicely, and so we've got a little bit of helper code in there that just makes sure that the server-side configuration understands that there's going to be some client-side routing as well, and they don't conflict in any awkward way. Okay? Not very interesting, not going to demonstrate it. But more interesting is some of the stuff that we've put in to help you build your code in an effective, efficient, productive, and fun manner. Build helpers. So what does this mean, and how does this help you? Let me show you a little example. I'll show you something that doesn't work very well, and then we'll figure out how we can fix it using these build helpers. So let's say we want to make a change to our code. Let's say we've got this counter page here, and some kind of business analyst comes in and they say, well, yes, I've analyzed your business practices, and I've found out that your staff could be at least 100% more efficient if every time this button was clicked, it went up in 2 instead of 1s, because then they would get twice as much work done per unit of time. And you say, OK, yeah, that makes sense. I understand why you get paid the big bucks now. So I will go and implement that amazing new business process that you've just invented there. So you go into your source code, and you say, OK, I'm going to change this page now. I'll rename it. So instead of counter, it's called double counter. Very good. And we'll change the TypeScript code as well. We'll change it so that when you increment, it goes up by 2 instead of by 1. Very good. And I'll save that as well. Let's see what effect this has, shall we? I'll go back to my browser, and I'll hit reload. And it has no effect whatsoever. It still says counter, and it still goes up by 1. So why is that? Well, it's because it's a TypeScript application, and obviously TypeScript has to be compiled. It's not understood natively by the browser. And in this particular case, we are using Webpack as a build and bundling system. That has got a lot of powerful functionality. I'll give you a few hints about what we're doing with that later. But for now, let's just say we want to use Webpack to recompile stuff. So we can do that very easily. For example, we can go into a command line window and manually just run Webpack if we want to. And that will work. It will work absolutely fine. It will recompile everything. It's rebuilt my JS and my CSS stuff. Now, if I come back here and I hit reload, then when it comes up, we've now got double counter, and it does, in fact, go up by 2. Pay rises all around. Brilliant. But it's not that great for you as a developer, because you have to keep remembering to recompile stuff all the time, which is a bit of a drain on your limited mental wisdom. I'm not, sorry. It's an inefficient use of your valuable time. That's what I meant. OK, so you want to rid yourself of this unpleasant task of having to run Webpack on the command line. What are you going to do? Well, maybe you set up some sort of file system watcher that's just going to see whenever a file changes on disk, it's going to run Webpack for you. Well, that will work, but it's not great because you never really know how long it's going to take to compile. You never know when it's finished, when you can safely refresh in the browser. Are you going to get a consistent set of files when you do refresh? Where are the compiler errors going to go? All that sort of thing. Can't we do a little bit better than that? And this is where we come to Webpack Dev Middleware. This is a feature of Webpack where the compiler for Webpack, instead of exiting when it's finished, it can stay in memory, and it can keep all the intermediate compilation states there so that it's ready to recompile very quickly using all the cached intermediate states. And it can also expose a kind of, it's a bit like a virtual file system that represents the output from the compiler. And then we can serve that virtual file system to the browser. So the browser is always seeing the compiled output, even though it's not even on disk. And it's smart enough to say that if a request comes in while compilation is in progress, it will just block it until it's got a consistent set of files. So you can just hit refresh as soon as you like. It will probably be done more or less instantly because it was already in memory. But even if not, it will wait the right amount of time before completing the request. So how can we use that? Well, we have made that available in these templates. In fact, it's enabled by default. But I just took it out just before this demo, just so that I could show you the effect of it not being there and then the effect of putting it in. So if you'd actually done it as a file new project, you would see some lines of code in there already like this. And this says, if we're in development mode, then we're going to use Webpack Dev Middleware. Now, this is only useful in development time. Technically, you could do this in production, but there isn't really much of a good reason to be dynamically recompiling your application when people are requesting it in production, because you could just build it once and then serve it from disk, and that would be more predictable and fast. But in development, it's pretty useful to be doing this. OK, so let's see the effect of this. I'll come back over here, and I'll hit reload. And initially, it will just look the same. But now I'm going to go and change my code again. I'll change it to triple counter. Now, the business analyst didn't even come up with this one. This is my invention. Okay, the idea with this one is that instead of going up with 2s, we're going to go up with 3s. Okay, so just bear with me. We'll see what happens. All right, so now I'm not going to run Webpack on the command line manually at all. I just hit reload, and immediately my astonishing innovation is right there for us all to see. Okay, so yes, thanks. So it's pretty good, right? But I still don't think this is as efficient as we could get, because I had to press the reload button manually just then. And you may be thinking that, you know, in the scale of all human suffering that anyone's ever had to endure, that pressing reload's not that bad. But if that's your attitude, then to be honest, I'm disappointed in you, and you should consider a different career, because laziness is such a virtue for a developer. But there are other reasons as well where it's highly desirable not to have to reload the page. For example, you may have a debugging session in process, and if you reload, then you've just wiped that all out. And there are other reasons, and I'm going to get to some of that later in this talk. So this brings us onto hot module replacement. This is a feature where we can see if the output of Webpack's virtual file system has changed. And if it has, we can push the changed code into the browser directly and update your application without it reloading the page. So let's see this at work. Now, this is another feature that would be there by default if I hadn't taken it out for this talk. So let me put it back in, and then you'll see what effect that has. I'm now saying hot module replacement equals true. That's all I have to do. So I'll wait for my .NET code to recompile there and the web server to come back up, and it probably happened about now. So I'll hit reload now, and we'll see. Again, initially it looks the same. But now, watch what happens when I change my code. I'm tired of this sort of slightly improving it, so I'm going to change to ultimate counter, and I'm going to make it go up by the biggest number I can. OK, I press save, and you'll see that I didn't even switch back to the browser, but it's already updated right there. And I'm going to change it to go up by the biggest number I know, which is 10. And when I press save there, I can go back to the browser, and now it will indeed go up by 10s. And I didn't have to reload at all. It has not refreshed the page. It's just changed the running code. Okay, I'll show you some examples of why that's even more useful later on. Okay, so that's hot replacement. What else have we got in terms of build helpers? Well, we've also got the ability to produce different builds, depending on whether you are targeting a development environment or a production environment. I'm sure that all of you in your existing code pretty much are going to already have some distinction between dev builds and production builds. So what does that look like in this kind of setup? And how is that actually controlled? OK, let me show you. So as I mentioned before, as I've mentioned about 10 times now, we're using Webpack. And as it happens, Webpack is configured through these config files. Now, we've got 4 different ones here. And I know that looks a little bit overwhelming. Why do you really need 4 different config files? Well, the truth is that really there's only one. And that's this one at the top, webpack.config. And the others are just overrides for different scenarios. For example, we've got this dev config file, okay? And what that says is that if we're in dev mode, we're going to include source maps in the built output. Whereas if we are in prod mode, we will not include source maps, but we will use uglify to minify the code. We've also got this vendor file. I'll explain that in a moment. But first, let's see how much of a difference this actually makes. Okay, so let's see how big the bundle of code that we're shipping to the browser is right now. So let's go into the browser dev tools, and we will see how much stuff it's loading. So I'll do a hard refresh, and we'll see that right now, to load this simple application, it's doing 11 requests and transferring 3.8 megabytes of JavaScript, which is a fairly disturbingly large amount of code. But that's because we're including all of the source maps, not just for our code, but in this case for all of Angular as well, which is enormous. So you would not want to be shipping all that to end users in production. So let's see what a difference it makes if we switch over into a production build. Okay, so I'm going to stop my web server here, and I'm going to change into a production configuration, and then I'm going to run Webpack, and I'm going to tell it to run with this vendor config. How many of you already do vendoring of your JavaScript libraries? Small number. I bet it's not a very well-known term in Microsoft circles. Basically, the idea is that you've got the code that you write, and then you've got all the third-party library code, which in this case would be Angular 2 and Bootstrap and some other stuff, probably. Now, the third-party code tends to be massive compared with yours. For example, Angular 2 on its own, even after minification, is 1.9 megabytes. It's massive. And to compile that, Webpack has to do tons of static analysis over it all to link all these modules together and figure out, if it all if it all builds correctly. And that, in this case, is taking 15 seconds. You don't want to wait that amount of time every time you make any change to your own code. So with the vendoring system, we can split that into a separate bundle that you don't rebuild most of the time. And then there's your code that just builds really fast. So now we've rebuilt that, we can just rebuild our code, and that'll go through much quicker. It doesn't have to do any analysis on Angular 2, and it produces this nice compact little bundle just containing the stuff for this application. OK, so now I've done that, let's run the application again and see what effect that has. So that's running about now. And I'm going to hit reload, and we'll see how much network traffic this moves now. We'll see it's now gone down from 11 to 8 requests, and from 3.8 to 2.1 megabytes. So 2.1 megabytes, still kind of disturbingly massive, right, for a small application. It's kind of fundamental today because Angular 2 on its own is 1.9 megs. But that problem is going to get a lot less very soon, because as soon as we can switch this over to Webpack 2, we will get a feature called tree shaking, which is just a ridiculous name for dead code in elimination. So any parts of the Angular libraries that you're not using will get stripped out. And the Angular 2 team have got a proof of concept that shows a Hello World Angular project dropping down to about 50 kilobytes with the tree shaking on. So that's the sort of size reduction that you should be getting when you do a production build, and will do pretty soon. Okay? So that's a fairly substantial improvement. Okay. Right then, what else? We've been thinking a little bit about the efficiency of shipping this, this application to the client right now. But let's think about the efficiency of it actually starting up and executing the code on the client. Let's see how long it takes right now. So every time I hit reload, you'll see that we see the word loading appear in the top left there. And it takes, what, like half a second or 1 second or something? Let's measure it quite precisely, shall we? I'm going to use this timeline tool here, and I'll hit reload. And Chrome is going to measure how long it took. And we should see that if we zoom in a little bit. I'll have to zoom out. OK, the screen changes from loading to loaded about, what, 700 milliseconds, something like that. OK, so that's the time it's taking to ship this bundle of code to the browser, and then for the browser to parse this big bundle of JavaScript and start executing the code. OK. Now, you might think that's not too bad. 700 milliseconds, like under a second, that's a fast application. What's the problem here? Well, that is not fast, because this is an incredibly artificial scenario. Like, for one thing, I'm running on localhost and literally on the same machine as my web server, which is like the most insanely fast network connection you can imagine. So that's not very realistic. And the other thing is, this is a pretty fast laptop, and some of your users are probably going to be using like a $50 Android phone or something like that. So the CPU in their machine is going to seriously struggle to even remotely approximate the performance of a decent laptop. It could easily be 10 or 20 times as long for the application to start up in their case. They may well be waiting 10 seconds plus before they actually even see it get beyond the loading thing for them. So what can we do about that? And can you imagine also if an even worse scenario occurred, like the absolute nightmare that keeps us all sweating at night, like this? Imagine if someone didn't have JavaScript enabled. What are they going to actually see in that case? Let's see. If I hit reload now, what we will see is the word loading. And that's just going to stay on the screen forever, which is not an optimal user experience, in my professional opinion. So can we do anything about that? Well, this is where we get into pre-rendering. Or you could call it having a universal app or an isomorphic app or whatever you want to call it. Basically, can we take all of the JavaScript for your application and can we run it on the server just like it runs on the client? Because we've got a pretty smart server on the back end there. Can't it manage this? Well, yes, it can. So let me show you how we can do that. Again, this is a feature that is enabled by default when you create a new project with these templates. And I've taken it out just so I can demo it to you. So it would have had some code in here. This is my main Razor view for this application, and inside there, you see I've got this app element, and this is where my Angular 2 application is getting bootstrapped into. And what you would normally have seen in there is a couple of ASP.NET Core tag helpers like this. So what I'm saying here is ASP.NET use these libraries that I've pre-installed to pre-render a JavaScript module, which is at this location client app boot server. Okay? So let's see that that's there. And that is, in fact, here. And as you can see from the file name extension, it's a TypeScript file. TypeScript can't be executed directly. It has to be compiled first, and that is why I'm also specifying the location of my Webpack config. Now, this is pretty cool because it means you can write your client-side application in any language that Webpack can compile, which is like any language that compiles to JavaScript, obviously, probably plus quite a few other things. And all of those can therefore run both on the client and by this system on the server too. So if I just save that now, let's see if this actually works. I'll switch back over here, and even though I've still got JavaScript disabled completely in the browser, when I hit reload, it takes a moment to come up the first time, but we will see that the Angular 2 application just pops up, even though there's no JavaScript enabled in the browser. And I can still navigate around, which is pretty nice. Okay, and let's see how much faster this is actually now then. So if I go onto the network tab, and I'm going to hit hard reload, then when we can actually see that, here it is, we can see that the application there was getting rendered in 98 milliseconds. So that's the time it's taken to execute the Angular application on the server there and ship the rendered HTML of the application down to the browser. So that's pretty good improvement, but we can make it better still because this is a Razor view, and Razor Views allows us to do all kinds of cool things. For example, I could take this section of the markup here, and I could just wrap it all up in a cache tag there. So I could say, well, after you've computed this once, for any other request to this URL, just use that same pre-rendered markup, and let's see what effect that has. So now I'll reload once, and the first time it has to populate the cache, but the second time I run it, it should be pretty quick. And we're seeing in this occasion, it's delivered the entire render Angular application to the browser in 3 milliseconds, which is pretty phenomenally fast, and that's obviously just as fast as any traditionally server-rendered application is ever going to be. Now, I've just shown you that it works in a sort of limited way without JavaScript, in that you can navigate around because these are just regular hyperlinks. It's all going to work fine. But not everything's going to work like that. For example, this button here, if I click it, nothing's going to happen. Well, how could it work? Because that button obviously is wired up to some Angular event, and there's no Angular because there's no client-side code. So obviously that's not going to work. So this is not really designed for the scenario where you don't have JavaScript. I mean, arguably it does help in that scenario with search engine optimization, but for actual end users, realistically, you probably are not going to support this scenario. The main reason why this is actually useful is just for the sheer performance of having your application rendered really quickly. So the application loads essentially instantly. There's no loading stage as far as the client is concerned. It's pre-rendered on the server. And then in the background, the client-side code is loading. And as soon as it's loaded, then it takes over, and the client-side logic works exactly like it normally would. Okay? So that is doing some pre-rendering on the server. Okay. Now, there are quite a few other features that are in these templates that I'm not going to have time to demonstrate in too much detail, so I'm just going to skip through a few of them now. One of them is a feature called cache priming. This is another performance feature. The idea here is that there's a very common pattern in single-page apps where you render your initial UI and send it down to the browser, and then the very first thing the browser does is it makes an AJAX request back to the server to fetch some data, which is not that smart, really, because if the server knew the client was going to ask for that data, why didn't it just send that data in the initial page? That would have saved an entire HTTP request. So the idea of cache priming is that you can specify a list of endpoints in your MVC application that the client is going to make a request to, and then we will pre-evaluate those requests, embed them in the page, and then whenever the client-side code was going to make an AJAX request to that endpoint, we will intercept it and give it the data that we've already got, and it will just resolve the request immediately without even talking to the server. So it's just a simple performance feature, that. We've also got some helpers for validation. As you can probably guess, Angular 2 has got a client-side validation thing, as well as React, and, well, you know, everything's got validation in it. You can't really get away from that. And on the server, in ASP.NET, obviously, you've got a server-side validation feature as well. In terms of Angular, we found that it was necessary to have a bit of helper logic to make these two things play together nicely. So if you have a server-side validation message, you want it to appear at the right place in an Angular 2 form, well, we've got some helpers to make sure that actually happens. And then another feature, lazy loading. This is a feature that's unique to the knockout template at the moment. We would be very happy to have that feature in the Angular and React and any other templates as well, as long as somebody can come up with a plausible way of doing it with those. We just haven't found one yet. But for the knockout one, it's very straightforward. So basically, the idea is that as part of the build process, you can nominate some different parts of your application that will be split off by Webpack into separate bundles. You don't even have to think about giving names to them or anything else. You just define a certain navigation point, and the code that's reached from that will go into a separate bundle on disk with some auto-generated name. And then it will automatically get loaded on demand as the user navigates around. So it's completely transparent to the user. It just means that you're not shipping the whole application up front. You're just sending it incrementally as the user moves around. OK, so that's a bunch of features for these templates. But so far, I've only shown you the Angular one. I want to show you a couple of features in the React templates before we move on to some other topic. Okay? So let me show you one thing that you can do really well with the React template. Okay? I'm going to stop this Angular application here, and I'm going to move into React Spa, which I've created before, which is basically a file new React project with the Yeoman templates. And I'm going to switch back into development mode and start that running. And so when that comes up, let's go here. And let's see what the React template looks like. Well, not surprisingly, it looks essentially the same. All of these templates produce more or less the same looking application. Slightly different information on this home screen here, but the same functionality, the same examples of what you can do, just now implemented in a React style. Okay? But one thing that the React library can do really well, quite a lot better than how things are set up in the Angular template at the moment, is that when it does the hot module replacement, it can preserve the state of the application very reliably. And this starts to show why it's useful that we're not refreshing the page when you make a change to your code. So let me show you an example. Let's say that we've been playing around with the application for a minute, and we've got a certain state in the browser's memory. Like in this case, I've got a current count value of 6. And now let's say I want to make a change to my code. OK, let's see the code for counter, shall we? So I'm going to show you my React single-page application here, and we'll find the counter component here. So again, it's a pretty simple bit of component. It's written in TypeScript. It imports the React library. It defines in TypeScript an interface to represent the sort of state that we've got here. It sets the initial state to be a count of 0. It's got an increment method that sets the count to be 1 more than it was before. And we've got a render, which displays the current count. And it's got a button that when you click it, it increments the count. Now, one thing that's a little bit different about React is that it's kind of strict about the way that you manage state. And it's kind of determined that your state needs to be kept in a sort of an official place that React knows about. And in some ways, that makes you a bit more restricted in the way that you can write your code. But it also comes with some benefits in terms of what we can do for you if you follow that pattern. So let's say that I want to make some change to my code now. I'm going to make a similar change to before, so I'll change this now to super counter, and I'll press Control-S, and the hot module replacement should kick in, and we'll see in the browser that it changes to super counter. But it has not lost the state of the application. It's just updated the code without losing that state. And I could change the procedural logic as well. Let's make it go up in tens now, for example. And when I switch back to the browser, it will now be going up in tens, even though it's still got its state as before. And I can do other things too, like let's say that when we display the current count, instead of just displaying it normally, I'm going to display it current count times 2. When I save that, it's going to change from 46 to 92, and then I can change it back, and it will change back. So this is pretty nice. This really starts to feel like you've got this live flow between your IDE and the application that's running in your browser. And it deals even with things that can go wrong as well. So let's say, for example, I make a mistake. Blue, blah, whatever. I try to call some function that doesn't even exist. I press save. What's it going to say? Nothing. Oh, there we go. It's done it. It's now said, cannot find name blah. OK, so I fix my obvious error in my code. I'll save it again. The error goes away, and my application's still there. It still hasn't lost its state. So this provides an extremely fluid and flexible kind of development experience for you. And this is why it's really useful that we're not throwing away the application state each time you change something. And in fact, if you want to take that a step further, you can look at the React and Redux template. How many of you are using Redux right now? That is more than I thought. That's probably like more than 5%. OK, so Redux is for those of the rest of you, Redux is an application architecture. It's not strictly speaking tied to React, but it's very often used with React because it kind of came out of that community and works very well with that. The idea of Redux is that it tracks all the states that your application has been through and the way that it's transitioned between each of these states. And the benefit of doing that is that you can always understand the state that your application's in. If something goes wrong, you can trace backwards through all the different transitions that it's been to and see exactly what caused whatever particular thing to go wrong actually caused it. And this plays really nicely with this sort of hot module replacement system. So let me give you an example of that. I'll kill this application and switch over to the React Redux spa, and I'll start that running. So when that comes up, I'm going to load that in the browser. And again, the React Redux template looks more or less the same as all the other ones. It's got the same 3 things in it, but now implemented with a Redux architecture. OK, so let's do the same thing that we did before. I'm going to get a particular state in the browser's memory. In fact, actually, I'm going to do it in navigation as well. So let's say we start on counter. I switch to home, switch back to counter. I'll press the button quite a few times. And let's say that at this stage, something went wrong, and you don't know why. So by now, because you're using Redux, you can pop open the Redux developer tools. And this will give us a list of all the different state transitions the application has gone through. For example, we can see that we did a location change in the URL history. We can see that these increment counts occurred. We can see this one is where we went from 2 up to 3, and we can trace back through that. We've also got this sort of crowd-pleasing UI here, where we can display this little slider. And using the slider, we can jump backwards and forwards through time. We can see exactly how the user has navigated around and what happened as they press buttons and what effect that had. Okay, and this is really cool if you when you're implementing some new functionality or when you discover some kind of a problem, because you can change your code and see what effect that would have had on the actions that the user performed. So as an example, let's say that we want to have some new rule that whenever the count is more than 10, we'll display a special message. But it's not doing that right now. It's just displaying the count. So let's see if we can implement this new feature in our application. I'll switch over to the counter under React Redux spa. And I'm not going to go through the code, but this is the little bit where it actually displays the current count. And I'll change it so that I'll say, if that value is less than 10, then we'll display it. Otherwise, we'll display this special message, stop clicking now. Okay? So when I save that and switch back, we'll see that it's immediately changed to stop clicking now because of the hot module replacement. But as I move the slider, we can see exactly when that message would have appeared. We can replay the user's actions throughout the whole history of the Redux store there with respect to our updated code, which is particularly cool if you, for example, you've reproduced a bug, but you're not quite sure how. You can slide back to before it happened. You can make a change to your code to see if that's going to fix it. And then you can try just moving the slider along and see if whatever problem you experienced has gone away now. So that is the sort of very friendly and modern development experience that we're trying to make available to you with these sorts of templates. OK. So that's enough about these project templates. I want to spend the last bit of the talk going through some of the technology that underpins this and look at 1 or 2 other ways that you could use it in different types of projects. So behind these project templates are a bunch of NuGet packages, which contain a lot of the logic and functionality for tying in with all these different services that I've been showing you. So for example, we've got packages called Angular services and React services, which deal with providing a lot of functionality for those type of applications. And like I've been saying repeatedly, we don't just want you to be limited to those things. We want you to be able to create your own stuff as well for other client-side technologies or for just whatever other type of project you want to build. And the functionality that these things have in common is all coming from a NuGet package called SPA services. And this deals with common facilities like being able to pre-render parts of your application on the server, having all these tie-ins with Webpack, with doing the tie-ins between server and client routing and other things like that. And this is agnostic to whatever type of client-side framework you're using. And you can use that with some other framework if you want to. Now, as for how that works internally, like how does it actually do the JavaScript rendering on the server? Well, it makes use of yet another NuGet package called Node services. And as you can probably guess from the name, the way that works is that it makes use of Node.js internally. So internally, in a hidden, headless way, it spins up instances of Node.js whenever it needs to. And it's got a very fast RPC layer that allows it to pass invocations into Node.js and get the result out. And it deals with all the messy stuff around process, lifetime management, recovery from errors, propagating errors that have occurred in Node through into your .NET application in the right kind of way, all the serialization and all that kind of stuff so that you don't have to deal with that. And you can make use of these libraries at whatever level is useful for you in your application. For example, if you just want to execute JavaScript code on the server, but you're not interested in any of the other sparse stuff, then you can just take a dependency on Node services directly, and then you've got JavaScript execution on the server. So why would you want to do that anyway? Well, probably the most compelling reason for running JavaScript on the server is the fact that you get access to all of the infrastructure from NPM. NPM, the Node Package Manager repository, is the biggest collection of open source software in the world that has ever existed. And anything you can think of is probably on there under 25 different modules. And so, you can get whatever functionality you like from there. And some things are only going to be there. For example, if you want to do some sort of transpilation at runtime on the server, that's going to be written in JavaScript, and so you're going to need to be running JavaScript on the server. Or let's say you want to do something that there isn't particularly great support in .NET Core for right now, like image processing or audio processing. There aren't particularly great libraries for that on .NET Core right now, but there's tons of stuff on NPM. So wouldn't it be cool if you could just use that from your ASP.NET project just as easily as if it was a .NET library? Well, not quite as easily, but not far off. So let me show you an example. Let's say we want to do some dynamic runtime image resizing on the server. So I'm going to kill this React application here, and I'm going to switch over into empty ASP.NET Core site. Now, this is not a single-page application. This is just a standard file new ASP.NET application, the sort of thing that comes out of Visual Studio today. And I'm going to get that running. So let's start that up, and we'll see what that looks like and what sort of functionality we want to put into that. So let's go to the home page for that. And you'll see that it looks like any other ASP.NET file new project thing. The only thing about it that I've changed is here on the About page, you see that we've got a directive that's come down from the marketing department that says we need an image of a parrot right here, okay? Important business requirement. So let's see if we can put our parrot image in right there. So we'll find the MVC view that is rendering that. We'll go into Views, Home, About here, and you'll see this is where the markup is, and this is where we need to make the image appear. Okay, now, just to save us a bit of time, I've already got hold of an image of a parrot. Right, here it is, isn't it lovely? This is what we want to have showing up in the page. So a very simple and obvious way of doing that would be to have a plain old image tag. Okay, so we can just drop our image tag in there. Let's see if that works, shall we? Will that work? Well, I'll hit reload, and, well, it sort of works, but it's probably not what they really wanted. Okay, obviously it's the wrong size, and we could resize it on the client if we wanted. We could say width equals whatever, but that's not a very smart move because we're still sending this massive image down to the client. And if we look at the size of that image, let's find out. It is 2.5 megabytes there. So that's not what we really want there. We want to resize it. Now, you could resize it on a sort of one-time basis manually in Photoshop, but don't do that. That's not cool. What is cool is doing it at runtime on the server. So let's do that. Obviously, the real reason is because you want to do it to different sizes at runtime and other things that justify your job, okay? Right, so instead of just having a pointer directly to the file on disk, I'm going to change that now so that it refers to this other URL. I've just prefixed it with resize, and I've put a query string parameter, width equals 300. Now, how are we going to make our application respond to this URL with a resized image? Well, one way that we could do that is we could set up a controller, and we could put some logic in there. So I've created this images controller, and there's no logic in there just yet, but let's start putting some in, shall we? Okay, so here's a starting point. let's just walk through this slowly, because there's quite a bit of code in here. The first thing says, this action is going to respond to any request that starts with resize / and then the rest of the URL is considered to be a variable called image path. Okay? And it's going to run asynchronously, and it's going to receive this image path as a string. It's also going to receive the width as an int that's going to come from the query string. And we're also going to ask the dependency injection system to give us an instance of iHosting environment. So what's that? Well, the use of it in this case is that it gives us the ability to read files out of the root directory in a nice, safe, fast way where we don't have to worry about directory traversal bugs or anything like that. So we can very quickly say, OK, is there a file under the root directory that matches this image path? If not, we'll just return a 404 not found. But if there is, well, we'll return this message. We don't really want to return a message, but we're just building this up incrementally. So let's hit save on that. And I'll go back over here, and we'll see what effect this has. So if I reload now, our image tag will be pointing to that action method, which returns a string. So it's not going to work, obviously, because the browser wants us to return an image, but we've actually returned a string, so we're getting this broken image instead. But that's OK, because we're just building this up. Let's see what the actual response from the server was. So I'll open this into a new tab, and you'll see that it did hit the code that we just wrote, and it has indeed matched the request to a particular file on disk. And it's correctly parsed the width out of the URL. Okay, so that's good. Now we can put in some logic that actually does some resizing. And like I've been saying, we'll do this using Node services so that we can use the Node image resizing libraries. And the way we can do that is like this. We'll say, OK, dependency injection system, please give me an instance of inode services. And what does that let us do? Well, let's get some IntelliSense, and then we'll be able to find out, shall we? So I'm just switching over to the empty ASP.NET thing. And when the IntelliSense starts, we'll be able to say, Node services, what have you got for us? OK, you've got various things. The important one, in this case, is invoke async. And that allows us to run some code inside Node.js. For example, we might have some code like this. We'll say, OK, Node services, I want to invoke a JavaScript module called imageresizer.js. And we can pass an arbitrary set of parameters to it. In this case, we'll pass the physical path of the file we want to resize and the width that we want to resize it to, and we'll get back a string. And we'll just return that string to the browser. Okay? So if that's going to work, I better actually create this file, imageresizer.js. So I'll do a new file, imageresizer.js, and I can start putting some Node.js code in here right now that we're going to invoke. And so a simple sort of hello world example would be like this. We'll export a function which creates a message, just a hello world style message that includes the current date. And we'll send that back to ASP.NET. We can do that asynchronously, so we've got a callback. We'll say there's no errors. We're just going to give you back this message. And ASP.NET will then pass that through to the browser. So if this all works, when I come back here and hit reload, instead of getting the message from .NET code, we're now going to see this message that comes back from our Node code. Okay? And every time I hit reload, it's going to produce a different time. Because ASP.NET is making this code very fast, very quickly into Node. We're getting the message back, and we're sending that onto the browser. So now we can put in any JavaScript logic we like. And because this is actually Node, we can make use of anything from the whole NPM ecosystem in the middle of our application. For example, we could use this NPM module called Sharp. Sharp is a very popular, fast and robust image manipulation library. And I can make use of that to do actual resizing. For example, I can say, all right then, Sharp, I want you to read this image from this physical path. I want you to resize it to this particular max width. And then I want you to not save that on disk, but just pipe the resulting binary data back as a stream to the result. Okay? And then back in .NET world, we can say it's not giving us a string anymore. It's now giving us a binary stream. So that will arrive as a standard .NET binary stream, and we can return that to the browser. So we'll say return file, and we can give it this result stream. And we need to give it a MIME type as well, image, JPEG. You could infer that dynamically from the file name or something, but this is fine for this demo. So I'll hit save on that. And let's see if this actually works and we get back an image in the browser now. So I'll hit reload, and indeed we do. So we get our 300 pixel wide image, and we could change it to other sizes, and it's going to work out correctly. And then back over here on the About page, I'll hit reload, and hopefully we will indeed see our actual parrot at roughly the right size. And let's check that it really is a lot smaller now. So I'll come over here and I'll hit reload. And we'll see that the image has gone down to 10 kilobytes now, which is quite a lot more reasonable. OK, so that is giving you a lot of additional possibilities as a developer to use Node code in the middle of your application, not just for image resizing, but for obviously anything else that it does. Last thing I'm going to show you in this talk is a new feature that I just put into these libraries last week, and that is the ability to debug your server-side Node code, which is written in TypeScript or JavaScript or whatever, in just the same way that you debug it when it's running on the client. This is really useful because sometimes you might have something in your application that only works properly on the client and seems to fail for some reason when it works on the server, and you'll be thinking, how on earth am I going to track that down? Like, how do I debug this stuff? You know how, I'm sure you are all very familiar with how to debug client-side code using your browser's debug tools, and you'll all be familiar with how to debug your server-side code in C# with Visual Studio or VS Code or whatever else you like. But it's certainly not obvious about how you're going to debug your JavaScript or TypeScript code when it's running on the server. So that's a feature that we just put in last week, and you can do it like this. So you go to the place where Node Services is registered with your dependency injection container. And if it isn't registered, then you can add it into the config like this and pass it this flag, launch with debugging true. That's all you have to do. So now I've done that. When my application comes back up, which is now, if I rerun this, we should see that amongst the plethora of other useful messages, we get this. Node.js debugging is enabled. To debug, run Node Inspector. You need to install it if you haven't already. Now, I have installed it already. So in some other command line window, I can run Node Inspector. And it will say, all right, I'm working. You can visit this URL in some browser window and start debugging your server-side code. So let's put that URL into my browser. And what you'll see comes up is something that looks exactly like the normal client-side debugging tools, but now it's showing you the server-side code. So this list of stuff over here is all the code that's on the server. You can see all my Node modules there. And importantly, you can see this image resizer.js file, which we've just written. And I wrote it in JavaScript, so you're seeing it in JavaScript. If I'd written it in TypeScript, you would be seeing it in TypeScript here because it correctly passes through all the source maps. So you can see the original language, you can set breakpoints on it, and debug it in the normal way. So I'll set a breakpoint right there, and when I hit reload, you'll see debugger paused. We're debugging now, and I've got my breakpoint here. I can hover over and see the variables and so on. And you can do all the other stuff that you normally do with your client-side debugging. For example, you can even go in and just start changing the code in memory without even changing it on disk. So let's say I want to put negate. I think that's the right syntax, I hope. So I'm going to press save on that, come over here and hit reload. And, oh, it's hit the breakpoint again. Press F8. And now we've got our psychedelic negated parrot. Okay? And you can do all the other things that you do. You can do performance profiling and everything like that. So all the normal debugging and performance-related tools that you're used to work for your server-side JavaScript just as they do for client-side as well. Okay. So there we go. That is all I'm going to have time to talk about in this talk. So if you want to try out any of this code, then please do so. Please go to this GitHub repo that I've put up on the screen here. This contains a lot of generally useful information. It contains all of the code that you've seen here. It contains all of the implementation code for all the libraries that I've been talking about here, the Node services, JavaScript, Angular services, Sparse services, whatever. All that stuff is on there. The project templates are all there. And there's also a ton of documentation on how you can use these libraries in your application in different ways. And how you can get started with using them. So please check that out and post some issues or some feedback and tell us what you think about that. And two last things I need to say to you. One is, if you've got any questions about this stuff, I would be very happy to answer them. I've been roped into doing some sort of Ask Me Anything thing immediately after this session. So if you come down to level 2 after this, you can ask me whatever questions you want about any of this. And the other thing is, please remember to evaluate this session on the way out. You hold the power to control next year's agenda, so express your opinion about whether you want more or less of this sort of thing. Please do the evals. And that is all. Thank you.